Hello everyone. Today we are going to discuss a problem from TIFR 2023. It's a matrix algebra problem where there is a sequence given. It's a real sequence such that xn plus 1 is equals to a matrix, and then it's xn. Now the matrix looks like root 3 by 2 half minus half and again root 3 by 2. Okay. Now we are curious about finding, if this is the condition, then what will be the limit n goes to infinity xn will be. There are four options given. Number one, xn is convergent. Number two, xn is not convergent. Number three, xn is not convergent, but there exists a convergent subsequence. And number four is xn, the norm of xn, I'm sorry, the limit of the norm of xn is equals to 0. Now these are the, you can see these are the basic four options of this sequence. Now there is another catch. I'm sorry, this sequence belongs to R2. So all the elements belongs to R2. Now let's see how we can address this problem. All right. Now if you can see that in this question, basically there can be many other ways that we can address the solution, or we can approach the solution, but the best way we will take here is we will take the help of linear transformation. Linear transformation. How? Because if we observe this matrix, this is nothing but a rotation matrix. As we can see, if some vector is given like this in a vector space V, and the entire thing has been rotated for minus theta, we can say, and there is a new vector b here, that is, suppose this is v and this is v prime. So we can see there is a relation between v prime and v is such that this is cosine theta sine theta minus sine theta and cos theta. All right. I'm sorry, into v, obviously. Now if we observe this matrix and this one carefully, we can see in our question, as it is given, xn plus 1 is equals to root 3 by 2, and as we all know, we can write root 3 by 2 as cos 30 degree. Next, half we can so we can replace this half as sine 30 degree. We can replace this minus half as minus sine 30 degree, and this one as again cosine 30 degree into xn. So basically what is happening is we have if this is our x1, it's getting rotated on the clockwise direction by 30 degrees and producing x2. And this matrix is happening forever, because since we are taking as limit x n goes to infinity, so n means the number of rotations and xn. So basically we are having an endless rotation where each rotation is for 30 degree. So from this we can see, we cannot say that where the xn is going to stop, because from x1 to xn again there is another 30 degree rotation and we are getting something called x3, and again the same matrix applied on x3, we are getting x4, and so on and so forth. It's an endless rotation. So since it's an endless rotation, we don't know where it's going to stop. Hence we can see this does not converge. So from this property we can come to this conclusion that this sequence limit xn does not converge because it's an endless rotating. Now we can easily disqualify this option, okay, and we will also disqualify this one because x can be any vector. So it is not necessary for a rotation, endless rotation, that the length of the vector has to be 0. So number 4 is also going to be cancelled. Now we also only have number 2 and 3. Now the question is, does the sequence xn has any convergent subsequence? Yes or no? Okay. So since it's a rotation, you can say that this is a periodic motion. And we can observe that in this 360 degree rotation, we are having 360 divided by 30, which is 12. So we are having the terms x1. So let's look at this picture one more time. So here was our x1. This is the number 1 position, say. From number 1, this vector is rotated to number 2. From number 2 to number 3. Number 3 to 4, 4 to 5, 5 to 6, 6 to 7, and so on. So after 11th rotation, when we are coming back to the we are again coming back to the first position. So again the cycle becomes 1, 2, 3, 4, 5, 6, 7, 8, and 11. So we can see that the sequence looks like 1, 2, 3, 4, 11. Again 1, 2, 3, 4, 11. And again this equation follows forever. Now from that we can see, obviously we're getting a constant sequence out of it. That is, if I take all the ones, suppose there is a sequence x and k such that 1, 1, 1, 1, dot dot dot. So this is obviously converging to 1. Or any sequence, like if it was 2, or okay, let's take 7, thala for a reason. 7, 7, 7. It is going to converge to 7. So obviously there is a convergent subsequence. So From that, we can say that our option 3 is correct. Okay, so this is how the question was addressed and solved. Okay, if you want, you can also give it a try and let us know in the comments.